So guys, welcome back to this channel, and if you are new here, kindly subscribe and don't forget to hit the notification button so that if we post any new video, you will be the first one to be notified this channel, so that we can improve our grades in engineering basically. So today we'll be looking at Q factors, or the quality factors. Previously we have been looking on the resonance, the series resonance. If you have not watched that video on series resonance, it's the previous video, you can go and watch it before you come to the Q factor. So at resonance, if the value of R is very small compared to the capacitive inductance and the inductive reactance, XL and XC, it is possible for the value of VL and VC to have a voltage many times greater than the supply voltage. So the voltage magnification of that circuit, which is equal to voltage across L or C voltage across L or C is equal to over the supply voltage. So the voltage magnification will be equal to the voltage drop across L and the voltage across. So you can draw the circuit here. We have the resistor, we have the inductor, and we have a capacitor here. This is the series. Let's see. So this current is flowing. This is R, this is L, and this is C. So the voltage drop across here is VL, and the voltage drop across C is VC. So they have said if the voltage drop across, if for instance this value here is very small, the value of the resistance is very small compared to XL here. Here we have XL and here we have XC. It is possible for these values VL and VC to have a voltage many times greater than the supply voltage. For this case is V. Because at resonance you know that Z is equal to R. So if this value is very small, you know that XL compared to XL and XC, the VL and VC will have the voltage drop greater than. So the voltage magnification, voltage drop is equal to voltage across L or C, voltage drop across over the supply voltage. So this ratio here is the measure of the quality of the circuit, as an resonator or a turning device. That is called the Q factor. So now I want to derive the expression for a Q factor. So Q factor is this one here. So in this case, the voltage drop across L is VL over the supply voltage is equal to V, and we know the voltage drop across VL is just simply the current multiplied the inductive reactance, which is of this case is XL. So E is equal to IXL over V is equal to IR. We know that V is equal to IR, which for this case I will cancel the I, so it will remain with XL over R. But we know XL is equal to 2 pi FR. The FR is the resonant frequency multiplied by L, and R is going to remain with that. So the Q factor will be equal to 2 pi FRL over R. Or this for if the supply voltage across the L. But for now, I want to look at this if the supply vector is across the x is x here. Alternatively, you can say q factor is equal to v. Q factor is equal to vc over q factor is equal to vc over v. For this case, we know vc is just simple I xc over and v just to ir, so it will be the q factor will be equal to this one will equal to I xc over I r. So I will cancel with I, will remain with xl or xc over r, and but we know xc will be equal to 1 over 2 pi frc. This fr is the resonant frequency. Fr is the resonant frequency. So at resonance, but you know at resonance Fr. So simply this expression here, this expression for the Q factor will be equal to 1 over 2 pi Fr C R. But at resonance, Fr is equal to, we derived this in our previous video. You can go and check on it if you have not checked it. Fr, resonant frequency, the expression for resonant frequency is just simply 1 over 2 pi the root of LC. From which, if you cross multiply here, this 2 pi cross multiplication of 2 pi will get, that is 2 pi Fr is equal to 1 over the root of LC. So from here, the Q factor is equal to 2 pi FRL over R. This one is this one here, which is equal to 1 over the root of LC. This is the FR. This is this expression here over FR multiplied by L over R. Then you can look at here. This one is equal to this expression here. This expression here is this one. We have derived it from here. We have just substituted it. Then L will just remain L here and R. So it remain with L over R. Then this expression here we have exchanged it with, substituted with this one here, 1 over LC. So from this we can get that this one L just equal to the root of L multiplied by the root of L, and the denominator here just equal to 1 over the root of L multiplied by the root of C. Then the numerator just equal to root of L over R. So 1L will cancel with an L, so remain with this R. Can put this R outside the bracket to remain with 1 over R into, then it remain with the root of L over here is the root of C. So the Q factor, the expression for the Q factor is this one here. Q factor is equal to 1 over R the root of L over C. The expression for Q factor is 1 over R L over C. We'll be looking at the example on the next video, so don't forget to follow up on our next video. So that's why I was telling you to hit the notification button. Thank you. See you next time. Bye bye.